Hi folks, welcome to this next video on the MAVLink for OpenTx and possibly HTX project. And in this video we are going to talk about this piece here. And this obviously is a module which can fit into your transmitter bay. And the key point here about this module is that it gives you full bidirectional MAVLink telemetry through your transmitter bay. So in this video, I'd like to discuss this a bit and show you how it's working and operating. And actually the real reason why I did this, I will tell you at the very end of this video. So stay tuned. So this is my Jumper T16 and this is how I was using it for more than a year. And when you look at the back, you can see the installation. And it was okay and it was great and it worked really well for me, but it's not an installation which is really extremely nice. I mean, what you had to do is you had to open the box, solder these wires to some points on the main board, and depending on your soldering skills, this was easy or not. And then you also had to build your voltage regulator and somewhere put your telemetry unit on it and so on and so forth. So I mean, this is this worked very great for me for over a year, but it's definitely not an installation which is the nicest in this world, right? I mean, this is not what one wants to use all the time. And even if you have a great transmitter like this Radio Master TX16S, which exposes the UART ports at the bottom, which makes the installation much simpler because you don't have to open the back and do the soldering job and so on and so forth. But nevertheless, I mean, you have here these wires going on. You need to somehow install your telemetry unit and so on and so forth. I really would have wished that they would have put a UART port here on the back so that at least you would have some short wires. But there is no doubt. Just take this here, plug it in, and ready to go. So let's discuss the operation of this thing. So the first thing you need to do, of course, take your module and plug it into your transmitter bay. So here I'm using my T16 for that here now. So I still have these wires coming out. So that's not something you need, right? In order to operate this, you don't need these wires. I just kept them obviously because they are there and they can be useful for whatever. So next, of course, you need to switch off on and we need to do some settings. So let's go briefly through the settings. And the MAVLink related parameters are located on two pages, the system menu and the model menu. So let's go first to the systems menu. You go to the back here and then you scroll down and then you find here this MAVLink baud rate 2, MAVLink baud rate, and then here the serial ports. And here you see that one serial port is enabled to operate as MAVLink, right? So this means that one of these wires here, in my case of a T16 or on a T16 and on a TX16S, one of these AUX ports would operate as a MAVLink port, but this is not what you need. So this is just how I've set it up now. I will come back to this in a second, but this is not what you need. So normally, if you just want to use this transmitter module, they both can be set to off here. Okay, so this is here. You basically don't have to do anything from the default. So the key setting is now found in the module setup. And when you scroll again to the back, you find here this usual MAVLink parameters, which are not relevant for now. The key setting here is this external RF module setting, where you can see that there is now a MAVLink option. And this enables here this transmitter module MAVLink option. You can see the light going. So if you just go into there, you can see that there are all these other external modules options which you have, like off or whatever, like a ghost or tracer or whatever. So if you switch it off, for example, you can see that this is indeed switched off. It's not working anymore. So what you obviously have to do, and that's the only thing you need to do, you go to this external RF option, you switch on your MAVLink, and then this is operating. So that's concerning the settings. So now it's fully working now, but there's no telemetry coming right now because my copter is not switched on. So I will switch on my copter. So this here is my copter, and I will switch it on. And when we will see, we will have. So now we need to wait a bit until the copter has booted up fully, and oh, it's coming already, right? So, and here we are, right? That's the typical script. So here the HUD is working and so on and so forth. And you know the script, I mean, we can go here for the camera page. So this copter has a gimbal installed, so we can move this gimbal up and down. So this is here what you can see here. So this is my gimbal with the camera. So we can move it up and down. And in this latest firmware version, which comes with this firmware for this transmitter module operation, now you can see, that where it's really receiving something. So that's nice. You can go here also to this main page, and when you press here this button, you get some pre-arm information. So obviously the autopilot is pre-armed, the gimbal is pre-armed, the camera is not switched on. So therefore that's why this is not pre-armed. And here, when you go here, you can get all your messages and so on and so forth. Okay, so this was it already concerning the setup which you need to do. So let's go a bit more into the details of what this module is actually doing for you. And all the magic which makes it working is obviously in the box here. So let's briefly open the box. So this here is my telemetry unit. That's a 3DR telemetry unit, but of course you can use any other MAVLink capable telemetry unit. And this obviously will also determine the shape or design of your box here, right? But here it's looking, for me it's looking like that. So let's just briefly open it to see what's inside the box. Okay, so here in the box you find this piece of hardware, right? And so this is a PCB I have designed. You can find the Eagle files in my GitHub repository, and this is a development board, so that's why it looks a bit more complicated than it actually has to be. There are more ports and more fields and so on and so forth, and here are some options. So what this actually has to do is it needs to translate the signals on the S port, which is located in your transmitter bay, into the proper standard UART TX and RX signals. And this is not, I mean, it's a standard approach to how this thing, so it's not really some creative invention of mine, but this is needed. And the reason why you need this is as follows. So here that's how it looked like. So this is your transmitter. And in the transmitter, on the module TX module, you only have one pin. Now through this one pin, you have to establish a bidirectional full MAVLink communication. That is, through this one wire, one pin, data must flow out and must flow in to that. And that's why you need such a splicing unit, so that you can, when you want to send in the out direction, you can go with upper path, right, this transmitting path, and when you want to receive, you can go through the lower path, and you need to switch between these two options. So that's quite standard. And this piece of hardware, this is already found in your transmitter. So what you need, obviously, is a piece of hardware which kind of reverts this, namely this here. So please focus. So here that in this transmitter module, right, there must be a piece of hardware which takes the signal on the S port pin and then splices it again into the proper directions, and then a microcontroller which exposes then the information which is transmitted through the S port pin as standard UART signals, which you can use then for any MAVLink telemetry unit. And this is what this PCB is doing. So as said, that's not very, that's standard electronics. You also, for example, find this in the multi-protocol modules, this sort of things. So that's just what you need in order to be able to establish it through the S port. The second piece or part of the story is that you also need to somehow define a protocol by which you communicate through the S port pin. And here I just want to give you a brief idea of how this protocol looks like. And now we want to do this MAVLink telemetry through this one pin. And how this is solved is that the transmitter, every, I think it's 20 milliseconds, or 20 microseconds, 20 milliseconds, 2 milliseconds, sorry, I'm wrong. Every 2 milliseconds, it sends a data packet from one direction, from the transmitter to the module. And if the module wants to send something back, it can send it back within these slots here it has available. So here you can see the packets sent out by the transmitter to the module, and here you can see the packets which are then returned back from the module to the transmitter with the proper timing. So we can also zoom in a bit. So this is what like one packet from the transmitter looks like. This is a packet from the module. And if the transmitter also wants to send something, then here it's now a longer packet from the transmitter to the module, and here from the module to the transmitter. So there's a bit of stuff which has to go on behind the scenes in order to get such a simple looking module to work properly to establish this bidirectional MAVLink connection. But the good thing is that's all available. So it's working. I'm using this since more than 2 months or something like this. So it's working great. And the only reason why it actually took me now 2 months to do this video is because I wanted to print such a nice 3D case here to have just a nice installation and be able to show this nice. Now all this material you can find on my GitHub repository. So no, this is not the right page, obviously. So let's go to here. Oh, I closed it already. Okay, so I just don't have it open right now. Here it is. So also you can find it on my GitHub repository. You find this folder S-Port Bridge, and in this folder you find the Eagle design files. You find some C code for the microcontroller, and here you find the STL files for this case. So you can start easily from there. Now the last thing I'd like to say is, and I promised this to you, that I will give at the end of this video, I will tell you my real reason why I actually was doing this. I mean, one reason to do this is obviously because this is just a nice simple installation, right, or installation option. But the real reason for doing this is actually here, this thing. So this is the CFM30 transmitter system, and so that's this thing here, and it has a LoRa 2.4 gigahertz module on it. And the cool thing is that it also has this additional hardware which you need. That is this piece of stuff here, but it also has this already inside the hardware. So when you open it, right, so this is the hardware, and there is a microcontroller as well as this kind of hardware is on here. So what this means here, this piece here can be used for full bidirectional MAVLink from the hardware side, and you don't have to do anything, you just have to buy it. And hopefully I will be able to develop some firmware for this unit, which gives you then this bidirectional MAVLink capability for this unit. So this is this was actually the real kicker for why I started doing this. So this thing here is basically just my development platform to go into this direction. Okay, thank you for your attention, and let's see you the next time.